हेलो स्टूडेंट्स, ये जो क्वेश्चन आप बोर्ड में देख रहे हो ना, वेरी इंपॉर्टेंट बिकॉज दिस टाइप ऑफ क्वेश्चन इज रिपीटेडली coming in the CBSE board examination. So let us see what is the question. And this question is from class 10th light chapter, students. The power of a lens is minus 0.25 diopter. Based on this information, find out the type of lens and its focal length. Given, students, here what power P is given, that is P is equal to minus 0.25 diopter. Okay, in bit number 1 it is asking what type of lens is it and its focal length. As you know, focal length of a lens is the reciprocal of its power. So f is equal to 1 by p. This is equal to 1 by minus 0.25. This is equal to 1 by 25 by 100. This is equal to, it will become, students, what, 100 by 25, right? That is equal to 25 4 char, that is minus 24, sorry, minus 4 meter or minus 400 centimeter, right? Then, students, in the second bit it is asking what, also in the first bit it was asked find the type of lens. As the focal length you got in minus, so the type of lens, students, will be what, that is a diverging lens, because concave lens focal length lies on the same side of the object, that is in the left side. So that is a concave lens. Okay, concave lens. Again, it is asked that, students, what the eye defect for which it may be used as a corrective lens. As you know, students, that there are three types of eye defect, that is myopia, hypermetropia, and presbyopia. Myopia is known as the short sightedness, in which the image is forming in front of the retina, not on the retina. And hypermetropia, image is forming behind the retina. Okay, so here, students, concave lens is used, that as it is a diverging lens, so if the image will form in front of the retina, if will little bit diverge the rays of light, then easily it will meet at the retina. So which type of lens, which type of defect can be corrected by using this concave lens? That is, students, myopia. Okay, myopia is generally corrected by using this concave lens. Okay, then, students, 3a, the nature and size of image formed by this lens when an object is placed between f and 2f from the optical center of the lens. So, students, it is a what, concave lens. Okay, so if you will draw the ray diagram, then, students, what will happen, where the image will form, you just see here, suppose that is f, that is 2f, f1, 2f1, that is f2, 2f2, right? Object is standing where now, between f and 2f, right here. Okay, object name is suppose AB, and if you draw the ray diagram, area coming parallel with the principal axis, after reflection it will appears to you that it will come from the back, it will come from the principal focus, yes or no? And another ray of light, if you draw through the optical center, it will pass by one deviation. So both the refracted ray of light are meeting between the optical center and the principal focus. So the image will form where, students, image will form between optical center and the principal focus. So image position between F and O. Okay, then asking, students, what the nature, as concave lens generally forming a virtual image, so the nature is virtual and erect, because virtual image is always erect, right? So nature of image is virtual and erect, right? So, students, in this way you can find out the answer of this type of question very easiest way. And if you have doubt in this question, please put in the comment box so that I can clear it out in the next video. Okay, thank you, have a nice day.